AI is quietly moving from can it generate to can it be trusted, scaled, and formally verified. This week's papers show three very different answers. One proves a decade-old quantum optimization result with a machine-checked theorem. Another makes high-resolution vision features cheap enough to run at scale. And the third exposes how AI app hubs can leak secrets through the very architecture they use to ship faster. The common thread is control over correctness, efficiency, and security. Keep watching, because the details here are exactly where the next wave of AI products will succeed or fail. Let's explore the first paper, a machine-verified proof of a quantum optimization conjecture. This paper reports a machine-verified proof of the Farhi-Golsom-Gutman conjecture for depth PQAOA on the ring of disagrees, a max-cut instance on an even cycle, showing that the optimal approximation ratio is exactly 2p plus 1, 2p plus 2, when 2p plus 2 is less than or equal to n. The proof was discovered with Claude Fable 5 and certified end-to-end in Lean 4, using a formalized quantum information library plus agentic auto-formalization tools. The key technical move is to decompose the Ising dynamics into independent momentum modes via Jordan-Wigner and Anderson pseudospins, then lift each mode to an SU2 sequence recognized as a quantum signal processing circuit. In that representation, simultaneous mode steering becomes a single polynomial interpolation problem. The residual energy collapses to 2, G21K, 2, and optimality requires a degree, 2p plus 1 polynomial with zeros at the p physical nodes, plus the unavoidable unsteerable point at k equals pi. This fixes the polynomial normalization to 1, 2p plus 2, and Feherij plus Ha factorization provide the complementary construction and inverse map back to QAOA angles. The result gives a complete structural explanation for a constant previously seen numerically, and shows that the proof itself can be generated by an LLM while Lean enforces correctness mechanically. Let's explore the second paper. Raise up ultralight universal feature upsampling via geometry-aware ray representation. Raise Up from Tongji University is an ultralight VFM-agnostic feature upsampling framework that reconstructs low-resolution outputs from foundation models such as DNOV2, DNOV3, SIGLIP2, and PE spatial at arbitrary target resolutions. Instead of plain 2D interpolation, it lifts reconstruction into a geometry-aware ray domain by combining a spatially decoupled guidance encoder, any resolution cross-attention, ray positional encoding based on 6 deplucker ray coordinates, and geometry-aware neighborhood attention. The design explicitly targets semantic fidelity and boundary sharpness while keeping computation small. The model uses only 0.14m parameters, about 16% of any up, and reaches roughly 7 times faster inference. On ImageNet trained upsampling, it achieves state-of-the-art or near state-of-the-state performance across CocoStuff, Pascal VOC, ADE20K, Cityscapes, Nayuviki, Davis, and proxy clip-style open vocabulary segmentation, with particularly strong gains on depth and surface normal estimation. The ablation results show that RayP is essential for geometric consistency, while the decoupled guidance encoder improves anisotropic structure modeling with only 0.14m parameters. Overall, Raise Up reframes universal feature upsampling as ray-aligned reconstruction, delivering a practical accuracy-efficiency trade-off that remains stable even at 2K times 2K resolution. Let's explore the third paper, Your Space is My Zone, Demystifying the Security Risks of AI-Powered Applications on Pre-trained Model Hubs. This paper, from Tsinghua University and QI Engson, is the first systematic security study of AI-powered applications on pre-trained model hubs, focusing on Hugging Face, Replicate, and Model Scope. The authors show that these AI apps are not just model front-ends, but cloud services with iframe embedding, token-based authentication, shared logs, and code reuse, creating 5 threat classes and 10 attack vectors. Their main technical contribution, Inzator, performs CodeQL-based data flow analysis over 972,546 public AI apps, collected from September 2024 to December 2025, and surfaces alarming ecosystem-wide exposure. 1,442 input injection candidates, 936 apps leaking credentials despite following secret handling guidelines, 27 backdoored AI apps, and 139,475 apps exposed to known Gradio RCE flaws. The study uncovers 3 novel architecture-induced attacks on Hugging Face and other hubs: ghost token, authentication bypass, and identifier reuse, along with log exfiltration, iframe privilege inheritance, code poisoning, runtime log leakage, container file leakage, and cryptojacking. Manual validation confirms substantial real-world impact, including 94 verified secret leaks from 500 sampled log leak candidates and 83 verified injections from 300 sampled input injection candidates. The authors responsibly disclosed findings, received $2,369 in bug bounties from Hugging Face, and report that 8 backdoored apps were removed after disclosure. That's a wrap on today's AI paper highlights. Thanks for watching.